Hello everyone. Consider this quantity. A is the summation of this factor, which is a complex number, multiplying this logarithm, the natural logarithm of this argument with this exponent. And we need to calculate the exponential of the negative a. First, we can rewrite this exponent here as 2 multiplying n minus 1. And then we will rewrite this term as I squared to the power of n minus 1. Now, we know that this exponent of the argument of this logarithm can be written as a factor multiplying the logarithm. And now we can observe that these two terms, they are equal to each other because I squared is equal to minus 1. And then we have minus 1 to the power of n minus 1 squared, or in other words, we can write it as minus 1 squared to the power of n minus 1. And that multiplies the logarithm. Now, minus 1 squared is equal to plus 1. Positive 1. So this term results in 1 to the power of n minus 1. But we know 1 to the power of n minus 1 is equal to 1, obviously. So the result is that a is equal to the summation over n from 1 to 1,000 of the logarithm of this quantity. What is the exponential of the negative of a? We know that the exponential of a sum, here we have this first term when n is equal to 1, when n is equal to 2, we have the second term and so on. So this is a summation. The exponential of a summation is equal to the product of the exponential of the first term multiplying the exponential of the second term, and so on. Obviously, we need to consider this negative sign here. So, the exponential of the negative of a is the product of the exponential of negative of this logarithm. And the productory is over n from 1 to 1,000. Okay, so now, this factor minus 1 multiplying the logarithm, we can rewrite that as the exponential of the logarithm, and this argument of the logarithm has this exponent, which is minus 1. And we know that this results in 1 over this argument here. In other words, we will have here the logarithm of n plus 2 over n plus 1. And we also know that the exponential and the natural logarithm, they are the inverse function of each other. So the result of that will be this argument here, which is n plus 2 over n plus 1. Okay, so the exponential of negative a is the productory of this term. When n is equal to 1, the first term, we will have 3 over 2. Multiplying the second term, which is when n is equal to 2, we will get 4 over 3, and so on, 5 over 4. When n is equal to 999, in the denominator we will get 1,000, and in the numerator 1,001. And the last term, when n equals 1,000, we will get 1,002 over 1,001. These two terms here, they will cancel out. These two terms will cancel out as well. Number 5 here will cancel out with the 5, which is in the denominator of the next term. The same here. This 1,000 in the denominator will cancel out with the 1,000 in the numerator of the previous term. These two terms will cancel out, and the remaining terms are 1,002 and 2. So we will get 1,002 over 2, and the exponential of the negative a is 501. The correct alternative is letter C.